Ladies and gentlemen, welcome to the airfield out here. Today we're going to be talking about weather radar on our aircraft. How to use it, safety things, all sorts of stuff. In this nose cone here, this bad boy, we got weather radar. We got the RTA 800 weather radar. We also have WX1000E storm scope. We're not sure what that means right now, but we'll be looking into it for you. Cut. Okay, so if you follow me, we're going to get in the aircraft, we're going to fire it up, and we're going to take a look at the radar. All right, follow me. Ladies and gentlemen, in this
the microphone.
Ladies and gentlemen, in the aircraft we have manuals. In this manual, it discusses in detail the weather radar operation. I'm just going to read a couple passages from the Bible, if you will. Weather radar operation. The primary function of the weather radar system is to aid the pilot in detection and avoidance of areas of precipitation. Turbulence weather radar aids the detection of precipitation-related turbulence in and around thunderstorms. The turbulence weather radar cannot detect clear air turbulence. And the weather radar cannot detect wind shear, clouds, or lightning. However, rain, wet hail, moderate to heavy snow, and in some instances, possible icing conditions can be detected by the system. The weather radar may also be used to map the terrain. Just going down here, an important note on the radar is the weather radar system should be used on every flight. This allows the pilot to verify proper operation and gain proficiency in operating the system on a regular basis. There's no significant weather in the immediate vicinity, or if operating a VMC, map mode may be selected, and the radar display can be compared with terrain features. Practice ground mapping on routes frequently flown and terminal areas in which you operate regularly. Ladies and gentlemen, here we are. To get to the radar, we click this button, radar. We have a bunch of different modes. We got gain, stabilization, test, standby, weather, map. So the first thing we'll do is let's go ahead and try and test the system and see what happens. So now it's going to run through a test. It's going to test the screen. I believe it's going to test the dish moving in the front of the aircraft, but it's not actually going to activate the radar. So that's something important to know. You can do this on the ground, obviously, if there's rampers in front of you. Not a big deal. All right, now, ladies and gentlemen, we'll go ahead and turn the radar on. We are on the ground. If you do this on the ground, make sure you're not on the ramp. Obviously, if there's anybody in front of you, it could hurt them. So we're in a safe area, nobody's in front of us. We're going to go ahead and turn the weather radar on. Now remember, you got to be really careful with the weather radar not to... Oh, shit! Now, when we turn the radar on, there's some important features with the radar. There's some components. We got the range of the radar, so how far we're looking out, same as the map display. And then there's another function on the radar. We'll go that up. And there's the tilt. The tilt goes up 15 plus or minus 15 degrees. So, guys, directly and gals, directly from the manual about the tilt. This is probably one of the most confusing parts of using the radar is adjusting the tilt. So I'm going to read directly from the manual. The tilt knob on the WXP is used to manually adjust the antenna tilt angle. The tilt range is plus or minus 15 degrees. Turning the tilt knob clockwise selects a positive or upward tilt angle, and turning the knob counterclockwise selects a negative downward tilt angle. The tilt knob remains functional while auto tilt is active, enabling the operator to change the tilt range ratio being maintained. Proper use of the tilt knob allows the operator to achieve the best picture of the storm cell size, height, and relative direction of movement. Procedures for adjusting the tilt knob may vary depending on user requirements. Proper use can only be achieved
through experience, regular practice.
Back to a good general practice. When operating over land, the best general guideline is to select a range that is within the line of sight distance to the horizon. Refer to the following illustration. I'll put that on the video here. Then adjust the antenna tilt until a small amount of ground clutter appears at about the outer third of the display. And that, you know, will give you generally a good tilt angle, especially if you're lost and not sure what's going on. Another cool component of this radar that I am guilty of not using too often is GCS. This stands for ground clutter suppression. So if you press this button, you'll see it goes from weather to GCS. So that's how you know this is in GCS mode. What this does is if you have it tilted down, especially, you're going to get a lot of returns from that radar, the radio waves hitting the ground and coming back, which will paint on your display. So what the GCS is going to do is going to recognize, it should recognize, it doesn't always work as advertised, but it should recognize, hey, that's the ground, it's going to declutter it on here for you and just hopefully pick up the weather itself. So this is something that you can play around with too. Okay, another important aspect of the radar that we've got to talk about is attenuation. The weather radar system, like all other airborne weather radars, has limitations that must be understood and recognized by the pilot. The first of these has to do with what the system can detect, and that's where attenuation comes in. Attenuation of the radar signal due to the distance is a function of basic physics. As a rule of thumb, doubling the distance to a target reduces the strength of the returning signal by at least a factor of 4, and in some instances by a factor of 16. Any return, green, yellow, red, or magenta from a distant storm usually indicates extremely high rates of rainfall and moderate to severe turbulence can be expected. The areas of rainfall should be avoided whenever possible. The second type of attenuation that can reduce the performance of the airborne weather radar system is attenuation due to precipitation. Moisture, especially rainfall, attenuates radar signals. The amount of attenuation due to precipitation depends entirely on the rainfall rate. And, Jade, if you could take a look at this. Obviously, we know black. This could be most likely nothing unless it's black behind a radar return. If there's black behind a radar return, that's an echo. That's not good. That doesn't mean it's clear there, most likely, 99% of the time. And green, we got light, yellow, and it goes up to bad. This is real bad. So keep that in mind. I think we're all familiar with the color scale here. Now, you still on, Jade? Okay, here we go. Going into the radar, we can click on the radar, the gain here. This is how we're going to change the gain. This is going to, this is lowering it and then increasing it. Okay, back to receiver gain. A variety of gain settings allow the crew to increase or decrease the receiver gain to analyze radar returns. Normally, receiver gain should be set to 0 or the norm position. 6 other positions, including 3 of increased gain, where the utmost sensitivity are available for analyzing the details of the returns. The higher settings are useful in identifying the lightest levels of precipitation, while the lower settings are useful for more in-depth studies of the most intense weather targets. Each of the minus settings, minus 1, 2, and 3, reduces the sensitivity of the radar system by approximately 1 color level. This results in a total reduction of 3 color levels when operating with the gain set to the minus 3 position. Therefore, if the target was magenta and norm, the same target at minus 3 will be almost totally removed from the display. Because of this effect, the weather radar system should not be operated in one of the reduced gain settings for an extended period of time. Thank you. We kind of glanced over it earlier, but there's another mode in here which I myself have not used quite often, but it's the map mode. So we click on, in radar here, we click on map mode. According to the manual, The rationale is map mode provides the most detailed ground returns that should be used while purposely mapping the terrain. This might be useful flying in mountainous terrain. For example, the Rockies would be a great place to use this. A technique might be to have one person in terrain and the other person in map mode with the radar on. Okay, back at it. I think this is going to be the final thing that we're going to talk about today. Stabilization. That button, Jade, if you look here, stab, we can turn it off, we can turn it on. Rationale. Antenna stabilization is used to eliminate the effects of aircraft pitch and roll to maintain a horizontal scan. Antenna stabilization uses inputs from the attitude heading system to eliminate the effects of the aircraft pitch and roll to maintain the selected horizontal scan. Antenna stabilization is normally on. Setting antenna stabilization to off is primarily useful in the event of an attitude signal failure. Setting antenna stabilization to off disconnects the inputs from the attitude heading system. Thank you. On these aircraft, we do have the NEXRAD. Be careful about using that. It's good to maintain your situational awareness. I think a lot of us are familiar with this. Okay, where's the storm generally located? How's it moving? That is excellent for that, this overall situational awareness. At night, in the thunderstorms and bad thunderstorms, you do not want to rely on this, the NEXRAD, as there is a delay. It will tell you what the delay is, but it's going to be up to 10 minutes. It depends on when it receives the satellite data, if you will. So just be really careful using this to pick your way through a storm. In fact, do not use this. Use the radar. Another important note is don't forget that in radar-controlled environments, which 99% of the United States is, don't be afraid to ask the controllers for help too on what they're seeing on their radar scopes. Thank you. You rolling?
Yep, we are.
All right, we're going to talk about the radar again in the storm scope. So go ahead.
So we don't do much about the radar, but the avionics guys are the ones who works on it. All we do is just to make sure like it's sealed and all that. So most of the time we call, we hire, like we contract Duncans who work on the avionics on it. So that's it I can say.
Okay, thank you very much. All right, that concludes our little introductory video to the radar. Remember, for your after landing checks, to make sure the radar is in standby. If you have any questions, hit up somebody else because I'm going on vacation.